Good morning to all. In this video, we discuss the design procedure of spur gear. To design this spur gear, we refer Design Data Handbook by Lingaya, Volume 2. Step 1. Identify the weaker member. Out of driver gear and driven gear, we identify the weaker gear and design the same. To decide the weaker member among the two, the following table has to be formulated. In this table, where sigma naught 1 and sigma naught 2 are the allowable statistics for pinion and gear respectively, and y1 and y2 are the Lewis form factor of pinion and gear respectively, then calculate the product of these two. If sigma naught 1 and sigma naught 2 are not given, then refer the table 23.18. For the pressure angle and tooth form, Lewis form factor Y for pinion and gear can be obtained by using the following formulas. Since load carrying capacity of the tooth is the function of the product sigma naught y, the meaning of this one is the gear whose value of sigma naught y is less is the weaker member. That is, if this condition is there, then pinion is the weaker member. If this condition is there, then gear is the weaker member. Design should be based on weaker member. Step 2. Design. First step in the step 2, to find out the tangential tooth load Ft. The tangential tooth load equation is given here. In this equation, where N is the weaker member speed in RPM, capital N is the power transmitted in kilowatt, R is the radius of the weaker member, CS is the service factor. That value is taken from the table 23.13. The value of CS will depends on the type of the load and type of the service is given. If condition is not given, assume medium shock and 8 to 10 hours duty per day. Second step, tangential tooth load from Lewis equation. The tangential tooth load from Lewis equation is given here. In this equation, where sigma naught is the allowable statistics of the weaker member, B is the face width, that range is in between 9.5 moduli to 12.5 moduli. Y is the Lewis form factor of the weaker member. P is the circular pitch. Vm is the pitch line velocity. D is the pitch circle diameter of the weaker member. N is the speed of the weaker member. Cv is the velocity factor. The value of Cv is taken based on the pitch line velocity. By equating the equation obtained from the steps A and B and by doing the trial and error method, find the moduli M. Select standard moduli from the table 23.3. Step 3. Check for the stress. First we calculate the induced stress. Then we calculate the allowable stress. If induced stress is less than the allowable stress, then the design is safe. Step 3. Dimensions. Calculate all important geometric parameters of tooth profile by using the equation given in the table 23.1. That is, find the addendum, dedendum, tooth thickness, total depth, clearance, outside diameter of the gear and pinion. Step 4. Checking. Check for the dynamic load. According to the Buckingham's equation, the dynamic load equation is given here. In this equation, all the parameter is known except the value of C, where C is the dynamic load factor or coefficient that depends upon the material, pressure angle and error in action. If class of gear is known, then error F is obtained from the figure 23.34a. Otherwise, based on velocity v, the error F is obtained from the figure 23.35a. Now, the value C is estimated from the table 23.32. To find out the value of C, we must know the material combination, the pressure angle alpha and error F. B-bit, endurance strength of the gear. The endurance strength of the equation is given here. In this equation, where capital Y is the pi y, y is the less form factor of the weaker member, sigma SF is the endurance limit. That value is taken from the table 23.33. For safer design, FF is greater than FD. C-bit, check for the wear load. According to the Buckingham's equation, wear load equation is given here. In this equation, D1 value is known, B value is known, where D1 is the pitch circle diameter of the pinion, B is the face width, Q is the ratio factor, K is the load stress factor, and E0 is the equivalent Young's modulus. Sigma Fs is the limiting stress for surface fatigue, and HB is the average Brinell hardness number. For safer design, FW is greater than the FD. If FW is less than the FD, then make one or more following changes. Increase the moduli, increase the face width, increase the surface hardness. Before solving the problem, first we go through the notations, where M is the moduli, Z1 is the number of teeth on the pinion, Z2 is the number of teeth on the gear, N1 is the speed of the pinion, N2 is the speed of the gear, I is the velocity ratio, alpha is the pressure angle, capital N is the power in kilowatt, FD is the dynamic tooth load, FT is the tangential tooth load, FW is the wear load. Sigma naught 1 and sigma naught 2 are the allowable stress of pinion and gear respectively. E1 and E2 are the Young's modulus of the pinion and gear respectively. E0 is the equivalent Young's modulus. Y is the lattice form factor. CS is the service factor. CV is the velocity factor. A is the center distance. B is the face width. P is the circular pitch, K is the load stress factor, Q is the ratio factor.